Hello, everyone. With this presentation, I would like to show you some basic programming that you can do with the MRT3 system. So this session is kind of busy because we have a little webcam looking at the setup here, the demo system, and then we have some files we have to do, and then later I had to pop up the MRT3 programming system. So let's go on with it. We discussed this time some basic interfacing of sensor, actuator, and the programming dongle that's going to be used. You probably see it here already here. We'll talk about something called reaction control approach. That's the approach that the MRT3 system uses to figure out how to solve a robotic problem. And then we'll actually get into and show you actually what it looks like, how to program in it, and how to program the robot and that sort of thing. And we'll apply that the IDE to a demo system that has some touch sensor, IR sensor. We'll use left and right motor. Also, we use a little speaker for sound generation. So the system hookup is here. Make sure you have the controller B, and we'll discuss in another presentation how to distinguish them. So left motor, of course, on the left motor, right motor on the right motor. The touch sensor is in input channel 1. IR sensor is input channel 3. And the speakers are out on out 4. So on the actual stuff, like this one here, is a touch sensor. Essentially, it's a button you can push down. So it's hooked up right here to the input 1. The input 1 actually just below the line, let's say remote control. And then we have the IR sensor here. It's on input number 3. And then you can see this is the right motor. Going to the right motor, left motor, the left. And on the output number 4, we have the speaker right here. Of course, you have the battery coming in here, and then power button, reset button, start button. All right, let's go on. So the dongle is a little bit close up here. You see it has a USB port, and it have a ribbon cable, 4-pin. You only use one way to can put it in, so you will be fine. So you can see. And when you enter the dongle, you can see it right now. This is lit up right here. And on the LED on the power is also lit up, but only slightly. And when you push on the power button, it says on brighter. And I already had some program before, so immediately the program starts running. Whatever I put in there before. We'll see. We'll get to that. We'll turn that off. Okay. So let's go on with that one. So first thing of all is this is very important for the dongle because USB, it gonna, as far as the computer goes, is some kind of communication port. So we go short of a COM port. And it's very important to make sure the right communication rate is done. So make sure on Windows, you have the Windows Manager and you go into that. I have a separate video that shows the actual steps. But just a reminder in here that make sure the COM port is set up to a correct rate, which is 115,200 bits per second. Data bit is 8-bit, parity is none, stub bit is 1, flow control is none. So all these down below are kind of standard, so you shouldn't have to change that. In case you don't like whatever COM port that the Windows Device Manager give you, you can go to Advanced button and you can change to the number that you like. For my system, I chose COM5 now. Okay. Let's talk for next to the reaction control approach. This is the approach that's used by the MRT3 system to help you sense some kind of condition and then make the robot do a certain thing. Okay, and the approach is quite simple. And so if you had to figure it out, so like you keep up a table, for example, that whatever bot you design, even a certain condition of a sensor or whatever, you need to figure out what robot action it needs to do appropriately for that given condition. Once you've done that, you can create like a condition action table here. Like for example, for condition 1, I need to take action A. Condition 2, I need an action B. For condition 3, I need action C. But who knows? Maybe there's condition 4 happen. I still gonna do action B. That's perfectly okay. The main idea is for each condition that corresponds an action, you need to figure that out. And then you're going to use this table essentially to create your program. So we'll show you how to use a basic MRT IDE. First, what we'll do is we're going to make a program from scratch. We want to monitor the touch sensor, which is this one. Okay, whenever I push down it, it should make the speaker over here make some kind of sound. Okay, and then let's do that first, and then let's go on with that. So when you install the MRT2 MRT software version 1.2, you should have an icon like that on the desktop somewhere. So I already got that started. So at the beginning, when you come in, it's all blank. You can hit program start, program end. We'll start to it. Make sure the right COM port for me is COM5. Okay, and then it have various folder, file, edit, set communication port. We can check that. Show that I'm COM5. So okay. Okay, there's some button build, make, download. We'll show you what to do. So let's recap now. So I want to monitor the touch sensor. And whenever the touch sensor is pushed, I want to make the speaker generate some kind of sound. Okay. So that means as input, I'm monitoring the button. Okay. So my button is into channel input 1. So I just go to the input, choose my button, which is my touch sensor. Double click on it. This menu come up. So here you have to remember. So I remember that I use this input 1 or input channel 1 and want to use it. And when it's pressed, this create my condition. I click OK. Okay, so it generate that. And then next, when this condition is true, that means if the touch sensor is pressed, I want to make some sound from the speaker, which is come in from output 4. So we can minimize that, or you can click on output. There's not enough room here, so let's bring it up. So in the output, it's a buzzer. I want the buzzer. And my buzzer is out on out 4. Use that. And you have two things to do. Frequency. You can go from 800 to 1800. So let's just say what I said before, whatever that sound is. For how long? 50 milliseconds here, and you can move the cursor. So 500, so that means it can do about half a second every time that you can make that sound. Okay, so let's say it's okay. So you can see that it put, this is a condition when the button is pressed. The output or the action is turning on the buzzer, ringing at 1274 Hertz for 500 milliseconds, which is half a second. And that's take care of this condition. Okay. Now, very importantly, you can see it does that, but always remember this one is we need to make sure that all conditions are covered. And so far, we covered that when it's pressed. Okay. So what happened when it's not pressed? Okay. So we want the buzzer to sound something else, perhaps, let's say. Okay. So in order to create a new condition statement or condition and action combination, you need to go to create a new one. So you have to go to this N here. So that means that the next condition that you put in will follow the N statement. And you also notice there's a minus sign here. If you minus it, it reduces so only you see the condition. So this kind of corresponds to condition 1. In action A, you can see it either you can show it or you can hide it. Okay. So let's say I highlight this one because I want to write a new condition after this one, which is like, for example, condition 2. So when I go back, I go to touch again. Remember, it's still on in 2, but I press when it's released. I'm looking for the condition when the touch sensor is released. Ah, error. You see, that's no good. It pushed inside that condition, so that's an error. Yes. So I had to leave it open, put it here, and go to touch, in use, release. Click OK. It's in the right place now. Because this action, buzzer R4, 1274 Hertz, 500 milliseconds belong to this condition. I'm creating a new condition, so it had to be separate from that. Now I'm ready. Go to output, and I say the buzzer again. And it's on output 4. You got to remember that. So it's going to be low frequency. And I'm going to make it a little bit shorter. Let's say only about 300 milliseconds. So the sound duration should be shorter when I release a button. Okay. Okay, so now you see that I create 2 conditions. Each of them have 1 action. And that's the extent about as far as logic goes that you need to know. You notice what is I have a touch sensor, so therefore only 2 possible states that it can be in. It is press or release. So when you start out the program, most likely you haven't got a chance to touch the button yet, so probably it's release. It will be taken care by this one. Okay. Okay. Next is by default, you notice up here, it saved this code as no name. Okay, so we want to save as something. And I found out, importantly, there's a bug in the system they're giving us now, version 1.2. Like, for example, I want to save this one with my own special name. You can go to Save As, and you can highlight the space. Like, for example, I put it in my C drive, in my PRJ file here, which is this folder right now. It's empty. So it's called save it. It's called project, and I'm going to save it as so we want this one is what touch buzzer because we're using the touch. I'm going to trigger the buzzer. Okay. Click save. Okay, it's save it. You notice here, you still say no name. Okay, so the software is back. You have to push the save program here. And then because it actually save it, but it doesn't change the label up here. So the software has a bug now. I want that to be changed. So because I already have touch buzzer, so it's just highlighted again. I click save. Yeah, just exist. No problem. Save. Now you can see it change to the touch buzzer. Okay. In this version 1.2, you can go to the code tab and it actually show you the actual C code. You can change it, but at least you can see that. So for you, those who know how to print program, see that's the main program can be executed. It initializes the microcontroller, and while one means it's basically an endless loop. Okay, an endless loop, you see it has those out to if thing condition. So this if statement rather. So this is a condition when the button is pressed, you turn on the buzzer, which is using a function called tone. Channel 4, that's the frequency, that's for how long. And if the button on channel 1 is released, you also use tone 4, frequency is 800 for 0.3 seconds. So you know this. So there's a while one around all this. So going back to the code, although we wrote like this, the actual computer, when it runs, it from start, program start, it runs through these code to the end, and then it repeat it again. So you keep on repeating this forever and ever. And you don't see it in here, but when you into the C code, you see that it's an endless loop that takes care of everybody in here. Okay. So this is important when you want to extend it or you're ready to learn C. Okay, so the program is done, and I save it to touch about the project. Make sure my compile is correct. Okay. Now you need to compile it, and in the computer language called make it. So you click on make. Down the output here, it should take some time. They're going to start having various statements running down here. They're kind of slow here. Let's see, let me try again. Oh, here we go. So when it ran, it has different signal beginning. It invoked the so-called WinPR cross compiler. So it trigger, you can tell by it is an 80 mega, that's a CPU, a microcontroller type. And it have a bunch of things. It's compiling that main C program you can see. Oh, it have a bunch of things, but eventually, hopefully, it's have an end and we have no error, which is good. It tell you that it's about this little program is already about 43.1% full, so it doesn't have much memory, you can see. Okay, when it's done, so I want you to concentrate on the video screen now. Right now, as you remember, the button is dimly lit. We need to turn it on first before we download the program. Right now, it's dimly lit because the power comes from the USB port, but the computer, the microcontroller here is not actually on yet. So put it on. Okay. So it's brighter, and immediately it ran whatever program was on it, which happened to be something else already. So that's the annoying part. So you click download, and then it tells you to click the reset button, which is here. When I push that, watch out, there's a blue light coming on solid, and it does it. Okay. It's waiting too long, so start flashing this message. So the only thing you need to turn it off. Let's see if we can get rid of this. Let me see if I can close this error signal. Oh, good. So download is error signal closed. We'll go back again. So we better be ready and do it quick, so that you can see that certain kind of period when it's way too long. It doesn't like it. So I turn it on again. It's running that. So I download. Now I can push the reset button. See it blank solid, and then it's going to become solid. And also you notice in here, there's a bar, progress bar start going. Okay, so now the new program is loaded, and you can see the motor went quiet because it's a new program, doesn't involve the motor, so they're not that quiet now. So we can push the start button to do it. Okay, let's see if it runs. Let's try it again. Reset button. So you see, when it's not pressed, it gives that sound, which is higher pitch. I push down. Okay. So remember when I press that high frequency for 500, and when I release, it gives a lower frequency and shorter time though. And so this is interesting part. According to the code, like I mentioned to you, the whole thing is inside an endless loop. But you can see that the buzzer, once it's given a certain sound, it won't repeat itself. So see, I push it only one time. I haven't released the button. That means if the code gonna run through this, it will come back, but it won't do this statement again. So the buzzer look like if you trigger it, it only do it one time. See how I release it? You go in here. Even though the program go back. You see that the touch button is based on temporarily. You see, all I have to touch it one time, and it will go into the press button. Hold it down doesn't change any of the consequence or the action. When you release one time, it goes in here. Okay, so hopefully you figure that one. So let's go back to our program. We say that add a new action. When the touch sensor button release, turn on the left motor also, which is this guy. Okay, and the left. So let's go back to our code because we want to do when the process is released, right? So right now the buzzer is making this sound. We want to add a second action in here. So we're going to add another action, which is another output. And we want to turn on the motor. And we want the lift motor. And we can do forward or backward, doesn't matter. Forward is speed of 10. Basically a number meaning 20 at full speed. Backwards full speed is -10. Stop is 0. So it's up to you. So let's say we go forward. Okay. Click OK. So you see it. So right now, every time I release the button, the buzzer will make that sound, and the motor will go forward also for a certain amount of time. Okay, when it's released. So you see that now, if you think about it, when this program is run, most likely I didn't push on the touch button. That means this condition will be immediately is encountered as soon as we start the new program. That means I'm going to do this one time and it turn on the motor. And you notice the same thing is in robot, if you turn the motor on and you don't change anything, it will keep on doing the same statement. So keep that in mind. So next, let's make it. Okay, it's still doing its stuff. Oh, maybe I hadn't saved it yet. So and let's save the oh, here we go. So take some time to do it. But remember, it's still under touch buzzer.vrj. Okay, so it takes some time to compile, but now I compile it. I make sure it's COM5 here. Sometimes it disappears. I'm not worried about that. So remember, the power is still on. Okay, so we can we can download. Immediately, I can go to reset button. Okay, here we go. Let's start downloading the new program. Okay, so the new program in there now. So in theory, when turning on, this left motor should immediately turn on. So reset button. The left button is over here. So the left motor, you see it turn on immediately. Every push, you notice what? It changed to the new sound, higher frequency valve. See, see 500. That's the high frequency, and you hear the 800. Hopefully, you can hear that even without the sounds of the noise of the power. Oh. Okay, so you notice what? The motor keep on turning no matter what I do. Because once it's on, it stay on. So the only thing you can do now is to turn the power off, and then everything stops. So you can see that I made an error in this one here, because when you turn the motor on, it won't do it. That means what? Whenever this condition here, when it's pressed, you gotta make sure that you turn the motor off if you don't like that situation. When you press it, you have to turn it off. So let's do here. And I go back. Well, I'm already on the output. So now motor, left motor, and I want it to stop. Okay. So I click OK. So now when I start running the program, it may run the program before. It will give this low frequency noise and turn it motor forward. But when I press it, will stop the motor. That kind of the plan. Okay. So let's save it. Unfortunately, under the same project name, which is okay. Now I can make it. Oh, look like we had to save every time you make it a little bit quicker here. Looks like. All right. And now make sure the power is on. Immediately you can see it run the previous program. So this part is kind of annoying, but you have to get used to it. Now I push the reset button. See it lit up. And then the download process, you can see from here, start going down. Okay. So ready to run now. Either you push the reset button. Immediately you see because the button release, it's going to go forward. But now if I push, see, after giving half a second of this sound, maybe switch here so we can do things here. So right now it's doing this sound and the motor. If I push down, it gives you this sound first before it stops it. And you see, because I keep on pressing, it will code will stay in here and trigger this. As soon as I release, it's gonna make the lower sound and then the left motor on. See that again? High frequency, I'm gonna push this high frequency for half a second and the left motor stop. Within half a second. As soon as I relieve, 800 hertz sound for 0.3 second, and then the motor moves. That. Okay. So now you're going to do that. So that's quite annoying. So it's in the power off. Okay. So the take-home lesson is you have to figure out all the possible conditions that you have, and then you better have at least one of these conditions. So we say the starting condition or the default position, where you probably turn everything off, all motor off, all sound off, so somehow. All right. So let me save as. So let's call it touch buzzer left motor, for example. Okay. So we got that. Okay. Let's cell get ready. So I'm just gonna have new. Good. So the new program, I'm gonna make something new coming up. So we did this example and learn a few things about reaction control approach. Make sure you have all the conditions, including the default one, or shall we say the standard condition where you probably don't do anything, but that's sort of like an action also. The default position or the default action. Okay, next we're going to be using the IR sensor And basically, the IR sensor really triggers as something is it sends something or it doesn't send something, and it have a very short range. You can see when I do the example. Okay, so the IR sensor is here, and what it does is it sends something very short. It really sends something close or it off very decent. So right now, let me turn it upside down, so it's aiming up. That means essentially it sends nothing. It doesn't sense any object right now. And so that's kind of equivalent to like when the IR sensor is high above the table. Okay, so I want both left and right motor forward position when the IR sensor is high above table. And when I move the sensor close to the table surface, I want to turn the motor going the other way. You can see that up to a certain point, they will switch direction. You can see that in pretty much real time. Let me prepare that, okay? So let's go back to the MRT software. So I just clear everything out. So it looks like every time you make something, you can clear it out. All right, so input again, but this time I use the IR sensor, which is here. And then you have to remember, this is input 1, 2, and 3. So IR sensor is on input number 3. So the program got started. So input, IR is on input 3. Okay, and then up to you. That means when it sends something, when it sends that the table is near right here. So what did we want it to do? Close the table, move left and right motor backward. Okay, that's fine. So we use it when it sends something. We click OK. So we got our condition. Now we need to figure out what to do when that condition happens. We go to output. We know we do some motor. Let's see, backward. Okay, the one motor left, go backward. To the right, go backward. It doesn't. It can be a different speed. Let's make it so this one is only about backward, but about 7%. Let's say. Okay, we click OK. You notice that because it didn't have enough room, so it didn't say everything. But if you put a code, you see that if the sense is true, left motor backward -10, right motor backward -8. It show you in here, right, this second. Okay, just doesn't have enough room, so they display, but it's there. All right, so when it sends, we want it to go backward, and then we want to figure it out when it's not sensing anything, right? So next, we go back to input, the IR, NO3, use it, and when it sends none, and when it sends none, what should it do? Both motor want to go forward. So output. And let's say we want the left to go forward but slower speed than the right motor now or something. Okay. Click OK. All right. So we can go to code. You see it's main program. Initialize the microcontroller unit. It has endless loop. If the IR on channel 3 sends something. Oh, what is that 980 value? Okay. That means the refracted intensity here, like it by default 950. Ah, interesting. That be equal to true. Then you left motor backward, right motor backward. If the IR3 is 0, basically equivalent to sensing none, is true. That means send nothing. Left motor forward, right motor forward, also different speed. Okay. And make sure we have the right COM port. Let's save it. And then so we save it as what now? So we'll use it as IR LR motors, so we can retrieve both motors. Click OK, so let's save that to change that. Good. Now we make it. It's doing its stuff. I can see the hard disk spinning. Down the result. Here we go. All right, it finally run it. It ends okay. Now to make it work, make sure I'm on power on. You're going to have the previous program again. You know the routine by now. Download and push the reset. Why not? And then start blinking, and it's downloading during that time. Yep, let me show that so you can see. See, it's to download the blue light blinking. Okay, because it's kind of hidden. But let me do it again. Download. And let this out of the way. Yep. You kind of hide it in there, but this why is it downloaded is blinking. Okay. Well, every time it's pushing that location, so it kind of remain hidden from us. So it's working. Reset. Okay. So it looks like both of them are running. Okay. If you have closed it, the goal is this is when it's not sensing. This is about somewhere when it's bouncing between two conditions. The lower it sends that it's some kind of an object. It doesn't sense any object at all. So this is about where it kind of the signal kind of bounce around between that zone. So when I look at this one, it's about I say about an inch. An inch is when it kind of in the limbo zone. So I think when it go the other way, so-called the forward motion here, and then you go, let's switch to the other one. Okay, so this is about where it is doesn't know what to do. Okay, I hope that I show you some of the basic of programming. The next time we program again, it will be for the skier robot.